Hello students, how are you? We again meet for our science lecture, our third lecture in physics topic. Okay, now in our last two lectures, we discussed about what is the electric current, what is the potential difference, right? Electric current means the flow of electron, flow of electric charge, that is called as the electric current, and potential difference means the work done, means some energy is required for the movement of the electron. So from these two topics we come to know that for the movement of the free electron in conductor, extra energy is required, some work is required, and that work should be called as the electrical potential difference. So we know that there is the relation between electrical potential difference and electric current, and logically we know that as we increase the potential difference, definitely electric current should be increased. But actually which type of relation is there? Okay, here that relation is direct relations or exponential relations. If I going to increase the potential difference 1 volt, so electric current will increase 1 ampere or 2 ampere, 1.5 ampere. What should be the relations? Which type of relation is there? Okay, so that relations was established by Ohms. So he is the German scientist. Okay, it derived the relationship between current and voltage. So to derive the relationship, he performed one experiment. Okay, here this is one circuit is there, closed circuit is there. In this circuit he used the variable battery, it is nothing but the variable battery. Variable battery means the battery in which we can set our voltage, means I can set the 1.5 voltage, I can set the 3 voltage. Okay, means I can change the voltage in this battery. There is no need to change the battery. Okay, here this circuit was established by the Ohms. Later on he installed one variable battery, he checked the current in the circuit with the help of ammeters. Now here initially use the low voltage, means 1.5 voltage set by the battery. Okay, so initially 1.5 voltage is adjusted by the Ohms. When he set the 1.5 voltage, on that time he observed that the current passing through the wire, for example, is the 0.1 ampere, right? Initially 0.1 ampere current was passed. Later on he increased the battery, means he installed one more cell in the battery, and the voltage increase, that is the 3.0. So what should be the increase in the current? So he checked the current quantity with the help of the ammeter. He observed that the current is become 0.2 ampere. Later on he add one more cell, so voltage is become 4.5, and he observed that the current is become 0.3 ampere. Later on again increase, and voltage is increased up to 6, current is become 0.4. Now here actually it is V upon I. Okay, so here when we take the ratio of V upon I, here it is 15, here also it is 15, here also it is 15, here also it is 15. So from this he come to know that ratio is remain constant, means between electrical potential difference and current there is a direct relation is there. He plot the graph of voltage versus electrical current. He observed that the straight line is received. It means there is the direct relationship between voltage and electric current. From this experiment he come to the conclusion, and that conclusion is given by the Ohms in form of statement, and that is called as Ohm's law. So Ohm's law is potential difference, that is the voltage, potential difference V across end of given metallic wire in the electric circuit is directly proportional to the current flowing through it, provided at its temperature. Okay, means the physical condition should remain constant. If the physical condition is going to change, definitely this relationship will be changed. So physical condition should remain constant. Okay, so that statement was given by the Ohms, and that is called as the Ohm's law. And on the basis of that statement, V is directly proportional to I. So we can write in this way, V proportional to the I. If I want to release the proportionality constant, so definitely there is need to, if I want to release the proportionality sign, there is need to place the proportionality constant. So V is equal to I, and R is the proportionality constant was given by Ohms. So V is equal to IR. If I make the R as a main component, so R is equal to V upon I. So R is a constant for the given metallic wire at a given temperature, and that R is called as a resistance, is the property of conductor to resist the flow of the charge, to resist the flow of electron. If I talk about the unit of R, so unit of R should be, what is the unit of V? V unit is the volt, I unit is the ampere. Okay, so unit of R should be volt upon ampere, but in honor of scientist Ohms, the unit of R is called as a ohm. Okay, it is represented by the Greek alphabets, that is this omega. Okay, so unit of R, unit of resistance is ohm, and it is denoted by the omega. Now if I want to define the 1 ohm, so according to Ohm's law, when the potential difference across the two end of the conductor is 1 voltage, means in the circuit, if the potential difference said that is the 1 voltage and current passed through the circuit is 1 ampere, then definitely the resistance of that circuit, of that conductor, is 1 ohm. So if the potential difference across the two end of the conductor is 1 volt and current that is passed from the conductor is 1 ampere, then definitely resistance of the conductor is 1 omega. Okay, so here, and we already established R is equal to V upon I. So can I write I is equal to V upon R? I is equal to V upon R. So here from these equations we can judge that, we can conclude that I is inversely proportional to R. So if the R, if the resistance is going to increase, so definitely current passing through the circuit is going to decrease. So if the voltage is remain constant and I want to change the current, then definitely I can change with the help of the resistor. So current through the resistor is inversely proportional to the resistance. So if the resistance is double, definitely current is become half. So many cases, suppose for example, if I talk about the any electronic gadgets, suppose if we discuss for the TV. So in the TV, different circuit is there, right? Different circuit is there. TV work with the help of the different circuit, and that all the circuit required the different current. Suppose one circuit required the 0.5 current, second circuit required the 1.5 ampere current, third circuit required the 4 ampere current. So here voltage that supplied to the TV that remain constant. So how we can modify that current? We can modify it with the help of modifying the resistance. Okay, so if I change the resistance, so definitely current that reach to that particular circuit is going to change. So in many practical cases, it is necessary to increase or decrease the current in the electric circuit. The component used to regulate the current without changing the voltage source is called as a variable resistance, and variable resistance can be achieved with the help of the resistor. In the electric circuit, the device called as a rheostat, okay, is often used to change the resistance in the circuit. Rheostat is nothing but the variable resistor, okay, is used to change the resistance in the circuit. Now this electrical resistance of the conductor, it is nothing but denoted by the R, right? Now R is the resistance. Why Ohms use the term resistance, not Ohm's constant, not any other terms used? He used the term resistance. Why? Because it retard the flow of electron. Okay, we will understand this concept with this activity. Okay, here one circuit is set. In this circuit 2 point is placed, X point and Y point. Now here between these 2 points we will set the different component. Initially I will place the nichrome wire between X and Y point. Later on I will place the 10-volt bulb between X and Y point. Later on finally I will place the torch bulb between the X and Y point. So when I change this nichrome wire with the 10-volt bulb, 10-volt bulb with the torch bulb, later on, means in this all the cases I observe that the current pass from the circuit, that is measured with the help of the ammeter, current pass from the circuit is not constant, is different. So what it indicates, when the electron is going to flow from the nichrome wire, is going to flow from the 10-volt bulb, is flow from the torch bulb, the resistance flow of electron is going to change. Retardations in flow of electron is going to change, and that retardation is a resistance. Means it is not easy way for the movement of electron. Force is required, energy is required, work is required for the movement of electron, but that electron movement is retarded by many reasons, and that retardation is called as a resistance. So here the certain component offer the easy path for the flow of electric current, while other provide the more resistance in the flow of electron, and when the electron is going to flow it will produce the electric current, right? So here when the electron is going to move, the electron is attracted by many surrounding components. Suppose for example electron is a negative charge particle. When electron force is provided over the electron and electron try to move in the forward direction, so some proton, some nucleus attract the electron toward itself. Why? Because the nucleus is the positive charge component, so it will attract the electron toward itself. So ultimately the movement of electron is going to retard it. So motions of electron through the conductor is retarded by its resistance. If retardation is more, we can say that resistance is more. If the retardation is less, we can say that resistance is less, and on the basis of that we can classify the material. We can classify the material. The component of the given size that offer the low resistance is a good conductor, and component that offer the more resistance is a proper resistor, otherwise a poor conductor of the electricity. So here on the basis of that resistance we can classify the material as a good conductor and poor conductor. So here the component offer the identical size that offer the high resistance is a poor conductor, as we discussed. Now here this is about the electrical resistance of the conductor. Now this electrical resistance of the conductor is influenced by which factors, means which factors will influence the resistance, which factor is responsible for the resistance of the conductor. Okay, if the resistance is less is the good conductor, if the resistance is more then the poor conductor. Now the conductor resistance is remain constant in all the conditions, or it is influenced by the other factors. So definitely the resistance of conductor is influenced by the different factors. Okay, so main 4 factors that is discussed here. First one is the nature of material. So it is obvious thing is that, okay, if the material is going to change, definitely the resistance is going to change. Suppose if I use the copper wire and if I use the aluminum wire, so definitely the flow, conductivity, conductance is not same, the flow of electron is not same, In copper wire, the electron can easily flow, while in aluminum wire, electron flow with the slight more retardation. So resistance of the conductor is definitely changed by changing the material. When the material is going to change, the resistance is going to change. Okay, if the resistance is minimum, then is a good conductor. If resistance is more, is the poor conductor. If I use the alloy, I think so you know that what is the meaning of alloy. Alloy means when the two metal is mixed uniformly, homogeneously mixed, then it will definitely produce the alloy. Two metals, otherwise metal, non-metals is homogeneously mixed and make the alloy. So metal alloy provide the more resistance compared to the parent metal. So nature of material influence the resistance of the conductor. Now second factor is a temperature. Second factor is the temperature. So temperature also affect the resistance of the conductor. Now how the temperature affect the resistance of the conductor? If the temperature is going to increase, conductivity is going to increase or decrease. So here, if the conductor is there, if a good conductor is there, if a good conductor is there, so definitely when the temperature increase, conductivity decrease, means the resistance is increased. Resistance is increased. When the temperature is increased, resistance is going to increase. Why? Because as we increase the temperature, kinetic energy of the subatomic particle is going to increase. Nucleus, electron, every subatomic particle kinetic energy is going to increase. As the kinetic energy is increased, the collisions between the subatomic particle is going to increase, and as the collision is increased, so definitely resistance is going to decrease. Assume that, okay, here one electron means one person is moving in the empty road and whole crowd is moving in the over the road. So which persons can easily flow, which person can easily walk, easily run? So definitely the single person can easily walk. So as the temperature is increased, the crowd collisions, the kinetic energy of the molecule is going to increase, the collision between the molecule is going to increase, subatomic particle is going to increase, ultimately flow of electron is going to decrease. So here temperature also affect the resistance of the conductor. Next factors, that is the length of wire and cross sections area of the wire. So here this both the factors can be understood by this activity. Here in this activity I will set one circuit. Here 1.5 battery is installed into the circuit. Now P and Q 2 point is there. Okay, now between these 2 point, initially I will place one wire with the length of L. I assume that the length is 1 meter. Here temporary assumption is there, length is 1 meter. I will install this particular wire, okay, here, and I will check the current and voltage. Current with the help of the ammeter and voltage with the help of the voltmeter. It is connected in parallel condition. Now I will remove that wire and I will install the 2 meter wire, length is 2L. I will install the 2 meter wire between P and Q point. Now I will measure the current and voltage. Voltage is remain constant, that is the 1.5 battery is there. Now current, when I measure the current, okay, so current is going to decrease, and when I check the relations between the current and voltage, we found that the resistance, because the resistance related with the current and voltage, resistance is going to increase and it become a double. Resistance is become a double. Here length is double, so resistance is also become a double. So here we come to the conclusions, resistance is directly proportional to length. As length is increased, resistance is also going to increase. Now the second experiment that we will perform, second activity that we will do, that is the same length is there, that is the L length, that is the 1 meter length is there. Now here I will use the same wire, material quality is same material is used, but I will use the thick wire. That cross section area is double, means here initially the cross section area is A, I can use the term 1 meter square is there. Now the cross section area is going to double. Okay, so when the cross section area is double, later on we will measure the current with the help of the ammeter, we will measure the voltage with the help of the voltmeter. Now from here we come to the conclusions, current is going to increase. The same length is there, but if the cross section area is going to increase, current passing from the circuit is going to increase. So it indicates that the resistance is going to decrease as the cross section area is going to increase. So we can say that the resistance is inversely proportional, resistance is inversely proportional to area. So these two relations that is established from this activity, that is the resistance of uniform metallic conductor is directly proportional to the length and inversely proportional to the cross section area. So we can write in this equations way, R is proportional to L and R is proportional to 1 upon A, means inversely proportional to the area. If I combine this both the equation, then I can write R proportional to L upon A, R proportional to L upon A. So R is equal to, if I want to remove the proportionality sign, so there is need to place the proportionality constant. So R is equal to rho L by A, R is equal to rho L by A, and this rho is called as a resistivity. This rho is constant of proportionality and is called as a electrical resistivity of the material. This resistivity is more important compared to resistance. Why? Because the resistance is going to change with the length, resistance is going to change with the cross section area, but the resistivity is the unique property of the material, is not going to change with the length, is not going to change with the area. Definitely it will change with the temperature, but the resistivity is the unique character of the material. For particular material, suppose if we set the temperature 25 degrees Celsius, so copper resistivity is remain same at 25 degrees Celsius at any place, at any copper. Okay, suppose if I take the 1 meter copper wire, suppose if I take the 2 meter copper wire, suppose if I take the 10 meter copper wire, the resistivity is remain same. So from resistivity we can judge, we can predict whether the given material is a good conductor or poor conductor or semiconductor. So resistivity is the important criteria, is the important property of the material compared to resistance. Why? Because the resistance is going to change with the length and area, that we already understand into the experiment, in the activity. So R is the resistivity. Here area and length effect is going to nullify. Okay, so here the rho is equal to cross multiplication is there, area is above and L is below, right? So can I write rho is equal to R A by L, rho is equal to R A by L. Now here what is the unit of R? Unit of R is ohm. What is the unit of A? Is the meter square. What is the unit of L? Is the meter. So here ohm meter square divided by meter. So ultimately what should be the unit of resistivity? Unit of resistivity is ohm meter. Ohm into meter is the ohm meter. So SI unit of resistivity is ohm meter. It is the characteristic property of the material, is not going to change with the length and area. So metal alloy have a low resistivity, means in the range of 10 raised to minus 8 ohm meter, sorry, ohm meter to 10 raised to minus 6 ohm meter, then this type of material should be classified as a good conductor of electricity. And if the resistivity of the material is too high, it is in the range of 10 raised to 12 to 10 raised to 17 ohm meter, then this type of material should be classified as a insulator. And if the resistivity in between these two, okay, if the resistivity of the material is minus 10 raised to minus 7 to, sorry, 10 raised to minus 5 to 10 raised to minus 1, then it should be called as a semiconductors. Okay, here poor conductors, and lastly 10 raised to 12 to 10 raised to 17 is called as a insulator. Now both resistance and resistivity of the material is varies with the temperature, because the temperature, as we increase the temperature, kinetic energy of subatomic particle is going to increase. So ultimately resistance as well as resistivity both is going to change. So this is about the resistivity of material. Resistivity of material is remain constant at particular temperature. So resistivity of the alloy is generally higher than its constituent metal. Definitely when the alloy is going to form, that resistance as well as that resistivity both is going to increase. So this type of alloy, that resistance is too high, and when the alloy is formed, that melting point is increased to higher level. So this alloy is used as a heating device. In electric iron is there, toaster is there. So alloy do not oxidize easily at a higher temperature, and for this reason they are used as a heating device in electric iron, in toaster, in electric iron, in toaster, in oven. Different heating device is there, heating device. Okay, they will receive the electricity, that resistance is too high, so this all the electricity is converted into the heat, and they will provide the heat to particular area, they will provide the heat in particular direction. So it will be act as the heating device. In iron is there, in toaster is there, in oven is there, even in bulb also. In bulb, whatever the old bulb was used, in that old bulb, the thin wire, thin spring wire that is used in the bulb, that wire is made up of the tungsten. Tungsten was used, okay, as a filament of the electric bulb. So here when the electricity is passed from the tungsten, this tungsten provide the maximum resistance, and that's why all the electricity is converted into the heat, and that tungsten wire become a hot, and they will provide the light, they will emit the light, they will emit the radiations. Okay, so here alloy can be used as a heating device. Okay, why? Because the resistivity of the alloy is too high compared to the corresponding metal. Okay, copper, aluminum is there, that resistivity is very less, so they cannot be used as a heating device. Okay, okay, so this is about the resistivity of the material. Okay, so here we will stop our lecture here. Thank you very much. We will meet you again with our next topic.